Hello Year 11. This required practical is the one from the Forces module, or one of them, and it's this one. It's required practical 19 on the combined, and it is this. So we have to investigate the effect of varying the force on the acceleration of an object with constant mass. So this you should pick up as being F equals m times by A. Force, mass and acceleration. It's Newton's second law. The equipment that we're going to use for this experiment is this ramp and rig made by Mr. Bowden and the technician. We've got a car of a known mass, constant mass, that doesn't change, and we've got some light gates. So this is the first light gate here, this is the second one. As you can see, as you brake, the beam, the data logger starts to start and stop it. The light comes on. This then ties in with the program of the computer, which is here, and it can tell us the acceleration at A, the speed at A and the speed at B. This is the light gate A and this is the light gate B, just for interest. The force that we will be applying on the trolley is from this. This is a mass. Each mass is 100 grams, as you can see. Now, for convenience sake, we'll say G is 10, even though we know G is 1.8. And we will say that each one of those is 1 Newton. So we'll start with the hook alone, which is 1 Newton. And if I start the program running and let the light gate through, you can see it comes up on the board there as the acceleration is 0.61 meters per second squared, the speed at A is 0.23, and it does speed up, therefore accelerating at 0.37. I've now constructed a table that I'm going to put my results on. Now, all good results tables have a variable and the unit that you're working in, and then all those relate to that unit. So we've just done 1 Newton, the hook on its own. We're then going to do 2 by adding a mass, 3, 4, 5, and we're going to put the acceleration here. So the acceleration for the first one is 0.61. Let's try it with a second mass. And that is 1.29. This one is loaded up to 3 newtons. Yeah, that is 1.61. Loaded to 4 newtons. 2.27. So there's our results. As you can see, it does increase as the force increases, the acceleration increases. But this is a special type of increase. It's a directly proportional increase. If we could do 0 newtons, we'd obviously see 0 acceleration. And then what do we know as a directly proportional line is a straight line that goes through 0. And we can see the red, the acceleration does show this roughly. On an ideal graph, we would see a straight line that goes like that, and the gradient would be the mass, but you don't need to know that. All you need to know is how the light gates work, the reason why it's proportional, and it relates back to the formula. F equals ma. F is proportional to acceleration, and that's it really. I mean, if we had more time, we would do repeats, and you do repeats to get a mean and reduce any anomalies. Hopefully we'd see, if we did repeats, we'd see an even better proportional line. that is that for that one. Don't forget to mention the equipment, the light gates, the formula, and the fact that it's proportional.